let's go to page 339 and let's do the odds. So number 1, you have vector A equal to 3i minus 4j minus 2k. And you have B equal to I minus 2j minus 2k. So you're looking for two things, the A cross B and the unit vector. So let's do the A cross B. So A cross B equal to I, j, and k. And now you have to watch the order. So this would be 3, negative 4, negative 2. And this would be 1, negative 2, negative 2. And you copy the first two columns so you can do the diagonals. So A cross B is equal to, so you do the diagonal, so it would be 8i plus negative 2j plus negative 6k. I kind of like to go below so I can line up the I, j, and k. And the one you go in opposite direction is always minus. So it would be minus the 4i minus negative 6j minus negative 4k. And then you just add it together. So A cross B equal to 4i plus 4j minus 2k. And to do a unit vector, you just divide by its length to get a length of 1. So unit vector, unit vector of this is first you get a direction, get the correct direction, and to get a correct length, unit vector means length of 1, so you have to divide by its length. So you square that. Okay, square that, and square that. So your unit vector equal to 4i plus 4j minus 2k divided by square root of 16 plus 16 plus 4. So unit vector equal to 4i plus 4j minus 2k over, you work it out, that is equal to 6. So unit vector equal to 2/3 I plus 2/3 j minus 1/3 k. Okay. Let's go to number 3. You have vector A equal to I plus j plus k. And you got vector B equal to I minus j minus k. So A cross B equal to I, j, and k. So you got 1, 1, 1, and you got 1, negative 1, negative 1. And again, copy the first two columns so you can do the diagonals. A cross B equal to, so this diagonal would be negative I plus j plus negative k minus, this one would be negative I minus, again when you go in this direction is minus, right? Negative j minus, this way is k. So A cross B equal to, this cancel out, this you get 2j minus 2k. And the unit vector would be, first get your direction, right? So get the direction correct, and to get a length of, unit vector means length of 1, so to get the length of 1 you have to divide by its length. So it would be 2 square plus negative 2 square. So unit vector equal to 2j minus 2k over square root of 8. And again, simplify. So each one of these, you're going to get square root of 2 over 2j minus square root of 2 over 2k. And it would be the unit vector. Okay, let's do number 5. Number 5, vector A is 4i minus 3j. Vector B is 3i plus 4j. So A cross B, equal to I, j, and k. And the A vector is 4, negative 3, 0. Vector B is 3, 4, 0. And you get I, 4, 3, j, negative 3, 4. So A cross B equal to this diagonal, so this equal to 0. This one equal to 0. This one is 16k minus the I is 0 minus the j equal to 0 minus this one is negative 9k. So A cross B equal to 25k. The unit vector would be equal to, first get the direction correct, then you have to divide by the length. So unit vector would be equal to k. Let's go to number 7. Okay, number 7, you're looking for the area of the parallelogram. Okay, so you have a vector A and B are adjacent side. So basically this is what you have. You have the, so you got vector A equal to 3i plus 2j. B is equal to I minus j. And so you're looking for this area. Okay. Again, so the area would be the normal. Okay, the normal, the length of the normal would be area of that parallelogram. So the normal is equal to A cross B, which is equal to I, j, and k. And again, watch your order, right? You have to go counterclockwise. So you have to go from A to B, right? So it'd be 3, 2, 0. And you got 1, negative 1, 0. And copy the first two columns so you can do the diagonals. Okay, so the normal is equal to, you go this way, you get 0 plus 0 plus negative 3k minus the I would be 0 minus the j is 0 minus the k will equal to 2k. Okay. So the normal will equal to negative 5k. So the area of the parallelogram equal to the length of the normal. Okay, and so this will equal to the, you just use Pythagorean theorem, so it'd be square root of negative 5 squared, right? So area of the parallelogram is equal to 5. Okay, let's go to number 9. Okay, so number 9, you have this parallelogram. So you got point A is 4, 1, 0. Point B, and you have to watch the order of the points. You always go counterclockwise or clockwise. So it'd be A, B, this would be C and D. So do not go A, B, C, D. Okay, you cannot go zigzag. You have to go A, B, C, D or A, B, C, D. Okay, so I'm going to go this way. So 1, 2, and 1. Point C is 0, 0, 6. D is 3, negative 1, 5. So to find the area of these, I'm going to take the cross product using the A as my reference. Okay. And so I need to get the vector AB and vector AD. So vector AB is equal to negative 3i. I have to subtract, right? Use the n minus at the beginning. 2 minus 1 is plus 1. 1 minus 0 is 1. Okay. And then the AD, vector AD, again, you have to use the D minus A, right? So this minus side is negative I minus 2j plus 5k. Okay. So the normal will equal to the AB cross, again, you have to go counterclockwise, right? Cross AD. Okay. So the normal equal to I, J, and K. And so AB is -3, 1, 1. And AD is -1, -2, 5. So copy the first two columns. So you got I, -3, -1. J, 1, -2. So normal will equal to, I can do the diagonal, so it would be 5I plus -J plus 6K minus the I would be -2I, -2I minus -15J minus -K. So again, you have to keep track of your minuses, okay? So N equal to 7I plus 14J plus 7K. So the area of this parallelogram will equal to the length of that. So it would be square root of the 7 square plus 14 square plus the 7 square. So the area of the parallelogram equal to the square root of 294. If you simplify a little bit, will equal to 7 square root of 6. Right? Then to get these, you go using the prime factorization. Right? So divide by 2, you get 147. Divide by 3, you get 49. Divide by 7, you get 7. Right? So that's how I get 7 square root of 6. Okay. Okay, let's go to number 11. Okay, number 11 is very similar, but this is the area of the triangle now instead of the parallelogram. Okay, so you have a triangle with the vertices. So you got A. So here's point A at -1, 3, 4. You got point B at 1, 2, 5. And point C at 2, -3, 1. And so you're looking for the area of the triangle. So again, I'm going to use the cross product. Now cross product give you the area of a parallelogram. So notice triangle is 1/2 of that, right? So keep that in mind. But right now, let's go and get the vector AB. Vector AB will equal to, again, you have to subtract, so you get 2I minus J plus K, right? So you minus, you get that. And vector AC, again, you have to use the C minus A. Use the end minus the beginning. So you're going to get 3I minus 6J minus 3K. Okay. So the normal is equal to AB cross AC, right? And so the normal equal to I, J, and K. So AB is 2, -1, 1. AC is 3, -6, -3. Copy the first two columns. And so N equal to, do the diagonals. So you got 3I plus 3J plus -12K minus the I would be -6I minus the J would be -6J minus the K would be -3K. So the normal is equal to 9I plus 9J minus 9K. Okay, so the area of the triangle, now this is a triangle, so it's going to be 1/2, right? If you look at before, remember the last one? From the previous one, this is a parallelogram, so it would be just the square root of those squares, right? But because it's a triangle, so you need to have 1/2. Right? Because the triangle is 1/2 the parallelogram. So you're going to get 9 square plus 9 square plus -9 square. So area of the triangle equal to 1/2 square root of 243. And then you can go and simplify. Well, actually from here you can just go and do the 9 already. So you're going to get 9 square root of 3. So area of the triangle equal to 9 square root of 3 over 2. Right? This is equal to 9 square root of 3. Okay, let's go to number 13. Okay, number 13, again, you got two vectors drawn from origin, and those are two sides. Okay, so here's your vector A equal to 2i minus 3j, and you got vector B is equal to I minus j, and you're looking for the area of the triangle. Right. So again, if you take the cross product, when you take the cross product, you will get the area of the parallelogram, and you just multiply by 1/2, right? Okay. So the normal equal to vector A cross vector B. So the normal equal to I, j, and k. And the A is 2, negative 3, 0. And this one would be 1, negative 1, 0. So you got I, 2, 1, j, negative 3, negative 1. So your normal is equal to, I can do the diagonal, so it would be 0 plus 0 plus minus 2k minus the I diagonal would be 0 minus the j diagonal is 0 minus the k diagonal is minus 3k. So the n equal to negative. Okay, so be careful. So this becomes plus 3, so it becomes positive k. And so area of the triangle equal to 1/2 of the magnitude of that, so it would be square root of 1 square. Right? Usual Pythagorean theorem. So there's only one number, so that's that. So area of the triangle equal to 1/2. Let's go to number 17. Number 17, it says, write the equation of the plane that contains the 3 points. So this is a picture that you have. So you have a plane and you have points. I'm going to call this P1 at 2, 1, 0. And put a P2 over here at 3, 0, 2, and point 3 over here at 0, 4, 3. Okay, so again, I'm going to use a product because to find the equation of the plane, you need to have a normal. Right? Normal tells you, give you the direction numbers. Okay, so here's your normal. So the normal, see over here, right? The normal is perpendicular to that, and it's perpendicular to this. Okay. So let's get the vectors first. So P1, P2 is equal to, again, you have to subtract. So it will be 3 minus 2 give you 1, 0 minus 1 give you negative 1, 2 minus 0 give you plus 2. Right? And then the P1, P3, again, you have to use the 3 minus the 1, right? So it would be negative 2i plus 3j plus 3k. Okay, so I'm going to do the cross product. So n equal to P1, P2 cross P1, P3. Right, so again, you cross, you use the right hand rule. Right? So the n equal to I, j, and k. And then P1, P2 is 1, negative 1, 2. The P1, P3 is negative 2, 3, 3. So copy the first two columns and do the diagonal. So n equal to the I diagonal is minus 3i plus minus 4j plus 3k. minus, this would be 6i minus 3j minus 2k. So your normal is going to be equal to negative 9i minus 7j plus k. And so from here, you're going to get the equation of negative 9x minus 7y plus 1z plus d equal to 0. Right? Again, so from normal, you get the equation. So now you have to look for d. Now to find d, you have to put the point on the normal in there, right? So put this point in there. So let's go off to the side. Let's look for d. So you got negative 9 times blank minus 7 times blank plus 1 times blank plus d equal to 0. Right? So again, you're looking for d. So you have to put a point in here. And the point you want to put in here, you want to put 210 in here because this point is on the normal, right? So put 210 in here. So you got negative 18 minus 7 plus 0 plus d equal to 0. Negative 25 plus d equal to 0. So d equal to 25. So once you find d, you put it back in here. So you got negative 9x minus 7y plus z plus 25 equal to 0. But normally with the general form, you don't want to begin with a negative. So you want to times by negative 1 to get rid of the negative in the beginning. So you're going to get 9x plus 7y minus z minus 25 equal to 0. Okay, and that would be equation of the plane.